So I have a customer that's desperately needing a gas stove for an apartment complex that they have, and we reasonably suspect that the igniter is bad on this. And I want to show you a quick, definitive way to test the igniter on this to make sure that everything is working for the oven. It's why people throw away a lot of gas stoves when they shouldn't. And I want to show you how to use a multimeter to make sure that this is exactly what's wrong with the igniter, to test and prove that it's bad. First thing that you want to do to eliminate other issues with this type of gas stove is to make sure that you turn the top of the stove on to make sure that you're getting a gas supply and it ignites, it sparks, you get flames, because if you don't, then there's either a regulator problem or a gas problem. But as long as the top works, before we even have to take really anything apart, with this really awesome way to use a multimeter and test.
To start this test, you want to make sure that the stove is plugged in and you can set the unit to bake and broil. And this unit operates a bit different than some GE ovens, and it just merely has a dial to set the temperature for the bake and broil. But as you can see, I can not only set it, but the igniter starts running as well, but we're still running into problems with getting the stove to operate. When the stove is plugged in, you want to remove the warming tray from the oven and wiggle your Rubenesque body underneath the oven. Once you're underneath the oven, you want to locate the safety valve, which is typically on the right side, and the wires that protrude from the GE stove. One set of wires will have a wire go to the broil igniter, which is typically blue, and then the other set of wires will go up to the bake igniter, which is pictured, which is the white wire. These are the two wires we want to test amperage with on our multimeter. Once you are ready, you're going to set your multimeter to amperage, which is usually marked with a 2/20A mark, which is the lower amperage setting, and then make sure the white wire is inside your clamp meter head. Make sure that it's easy for you to view the range that it shows on the multimeter. Now you're going to go up to the oven control board and set the bake for some reasonable high value between 350 and 450 degrees Fahrenheit to test and see how it works. Then go back underneath the oven and observe what the amp meter shows. In the case of this oven, the camera helps document exactly what we see over the next minute or two. The igniter should increase its amperage between 2.8 and 3.4 amps. This directly correlates to how hot the igniter should get in the oven and whether or not the safety valve opens up to allow gas to flow into the oven to cook your food. You see that over the course of a minute, it only reaches a maximum of 2.7 amps and then drops down to about 2.59. This is likely not good enough to keep the oven lit over time and suggests that the igniter works but is starting to go bad. But to be sure, let's test the broil igniter as well. Take your multimeter amp clamp off the white bake wire now that the control's turned off and put it on the blue broil wire. Now we're going to run the test by turning the broil all the way on, and there's only one setting instead. You notice when we turn the broil on, the amperage jumps much faster and much higher to about 3.38 and then slowly settles down to about 2.85 over the course of a minute or two. This is a notably higher value, showing a sizable difference in amperages between the lower bake igniter and the upper broil igniter, suggesting again that the igniter is bad. If you don't get any amperage when you try this trick, then the igniter is typically bad because there's a physical break in the igniter, which prevents the current going through the entire igniter. At this point, I want to show you how to replace the igniter real quick. So first off, you want to unplug the stove from the electricity, since we're going to unplug a few wires. Getting to the igniter is very straightforward. There are typically two thumb screws in the rear of most ovens that can be loosened with a flathead screwdriver and then removed with your fingers or the screwdriver. Once you have these out, you can pull up on the back of the tray and then out to reveal the baking igniter. You can see from this point that the igniter is clearly going bad with this terrible oxidation on the front of the igniter. It's really a surprise that this even works at all. Depending on your style of igniter, sometimes you can remove the igniter with two screws on the burner tube itself, but they're in a very difficult position that's going to require me to remove the entire gas tube. And to do that, we want to start removing the screw on the front of the tube with a 1/4-inch hex head screwdriver or drill gun. Then underneath there are two more hex head screws that hold the gas tube onto the stove chassis itself. It's quite tight, so I have to use a screwdriver rather than a gun to remove them. Once they are removed, I can then remove the wire going to the safety valve from the igniter, then from the igniter going to the control board, which is this wire harness. When both of these wires are removed, I can lift the gas tube up and out of the oven to work on the igniter system more easily. You can see now where the 2 hex head screws are on this gas tube and how it would have been impossible to remove them unless I had removed this gas tube on this particular GE range. Once these 2 screws are off, we can inspect how bad this old igniter was that was damaged. For the replacement igniter, I'm using an ERP GR403 igniter, which costs less than half of the GE OEM igniter, and it's an exact match in form and function of the GE unit. Make sure to take special care when reinstalling the new igniter because you don't want to touch your fingers on the heating coil that's inside the metal cage of the igniter. Oil on your fingers could get to the coil, which would cause it to rapidly degrade during use and will fail prematurely. Now, there is one difference between the ERP igniter and the GE, which is the wire harness connector. We can use a set of wire strippers and then the included ceramic wire nut to mate the ERP wire and the stripped GE connector together. Doing this is easy and it takes just any sort of generic wire stripper that you would probably have at your house. I'm going to cut the GE igniter wire in half, strip the aluminum back by maybe ½ an inch, and then twist the wire pair together between the GE harness connector with the ERP igniter to give me a longer wire that will properly connect to the control board on this. And again, I'm saving a lot of money by using these steps, which take maybe 3 or 4 minutes. When it comes to dealing with this igniter installation, this trick works on pretty much any brand oven and style well beyond GE, and I will have a link to a few of these style igniters in the description and the comments of this video. Now, once you have the wires installed properly on the igniter, we're going to go ahead and reinstall the igniter to the gas tube through the 2 hex head screws, and now we can reinstall the gas tube. We're going to take the gas tube and slowly insert it back into the rear of the oven housing, making sure that the 2 igniter wires go down into the warming tray area. These sometimes don't like to fit, so you need to take some time to ensure that the tube and wires fit properly. Underneath the gas stove again, fit your Rubenesque body in and make sure the gas tube is fitted up to the top of the oven gas orifice. Then attach the 2 wires to their proper areas, one on the safety valve and then one on the harness going to the board. It's a tight fit for the second spade connector, but it seems to look good. Then you're going to want to reattach the hex head screws to secure the gas tube to the oven housing via the 3 screws. When you have all these screws back in place, you can go ahead and test the oven back in by plugging it in. Let's go ahead and attach the amp clamp again and fire up the bake element to see what happens. Well, you can see that it acts much different this time with a new igniter because the meter shoots up almost immediately to 3.5 amps and then slowly goes down to 3.0, which is a much higher amperage than the original igniter, which will open the valve now. You can see that this one looks quite healthy with the lights off and starting to heat up, and we've solved the problem with this stove. All that's left is putting the bottom of the oven back plate in. You're going to angle it in and then slide the plate into the front of the area of the oven housing and then drop the rear of the plate back where the thumb screws go. This can be pretty specific between each different model, and you may need to move the plate around slightly to make sure the thumb screws fit in, but it wasn't too hard of a job. With the screws in, we can run the oven test again and see that there's this nice healthy glow on the oven compared to when we originally began, and we can test with gas now as needed.
So we went ahead and diagnosed the bad igniter in this, replaced it, and did all that in just, I don't know, like 20 minutes, even filming with a bum finger. So if I can do it with a bum finger with a camera in my face, it's really easy to do this. We're going to clean this off camera and we will have it sold probably tomorrow morning. But easy way to look at the igniter, even if it's warming up and it looks fine, it really wasn't fine. You saw on the camera, it jumped to 3.3 as soon as we put the new one in very, very quickly, similar to the broil. So hopefully this video helps you diagnose it. Even though this is a GE, an older GE, this will work on any brand, any make, any model. They may come apart just a little bit differently, and obviously the cords and cables, connectors are going to be different, but the universal GR403 we used worked great. Took me, 10 minutes maybe start to finish to do all this. So I hope it helps you. Have a great day. Bye.